All right, we're going to keep going. We've got cross sections and solids of rotations today. That's going to be on 142 and 143. There's a foldable for both pages. So we're going to label these and then we're going to write on those. So 142, it's 19.1, cross sections and solids of rotation. Okay, so 143 is the same. We're going to come back and glue things on here. On page 143. Okay. All right, so you've got two handouts. One of them is reteach. We're going to go ahead and start with that one. We'll cut it down a little later, but anyway. So we're talking about cross-sections and solids of rotations. This kind of has to do with some of the surface area and stuff we talked about before, and shapes. Basically, we're going to have a 3D shape, talk about what kind of a 2D shape it would make. So first of all, a net is a diagram of the surfaces of a three-dimensional figure. If the net is folded along the lines in the figure in the same direction, the net would form a rectangular prism. So this would create a rectangular prism. Our job is to determine what these would create. Okay. So this one has two circle bases and then a rectangle, which if you fold that around, this turns into a cylinder. So the answer is cylinder. Okay, this one, I have a base, and I have 1, 2, 3, 4. Those would all fold up into a rectangular pyramid, because I do not have more than one base, so it can't be a prism. Okay. All right, that is a net. We will talk about those in just a moment. Now, a cross section. A cross section is a region of a plane that intersects a solid figure, such as this right here. A cross section is often a two-dimensional figure, such as a circle, parallelogram, or triangle. It can actually be any two-dimensional figure, square even. In the figure, a cross section of a cylinder is shown. The cross section is parallel to the base. So the cross section, this is a cross section, it means slicing through something, is a circle. I want you to understand the difference between a parallel, this is parallel cross section, and a perpendicular cross section. I'm going to put that in blue. A perpendicular cross section would cut it through here. And it would actually create a rectangle and a cylinder. So you need to know the difference between the two. Okay. And I actually therefore just answered number 3. Draw the figures described below and name the cross section. I'm not going to redraw it because I drew it right here. A cylinder with a cross section perpendicular, meaning it meets at a right angle, to the bases is a rectangle. We will draw the others. Okay. A cone with a cross section perpendicular to the bases. Best of our ability, we're going to draw a cone and make a cross section that is perpendicular. Means it cuts it through here. It cuts it through right here and goes straight down. This actually makes a triangle. It's almost like saying in a perpendicular, if you took and you split it in half and opened it up and looked at it, what would be there? Okay. A cone with a cross section parallel to its base. Meaning, if it cut it through here, what would this be? And it just so happens it would be a circle. Okay. So what's going on with these? All right, we're going to cut this and glue it in on 142. And then we're going to do some more examples. Let's cut it and glue it to 142. That should fit just about right. Close. Okay, we're going to do another one that's attached to this video. It's going to go on 143. We'll cut it as well in a moment. Okay, and basically we're just practicing what we just did. Okay, problems 1 through 6 tell what kind of solid can be made from each net. If there's no solid that can be made, get with the given net, write none. All right, in number 1, if you fold this, it actually would make the top of the pyramid, but it would not have a base. We would actually need an extra piece for this to make a base. So it doesn't have any, it's got an open hole there. If, for whatever reason, you have a hard time visualizing these, you are more than welcome to trace them and fold them. Okay? All right, this one, let me see. It's got squares on each side, so that would be, that's helpful. That all folds down. And it's got a second base. So this does work. This creates a 1, 2, 3, 4, 5, 6 hexagonal prism. It's got 2 bases. That's required. Okay. This one, if you fold this in, it's going to be a rectangular prism. A triangular prism. This looks like it's going to be a cylinder, but if you roll this, your bases are going to end up overlapping and you will not have one down here. So this does not create anything. It's got an open hole. Okay, this one is very similar to this one. However, the way this one is created, if you fold it, it actually will create a triangular pyramid. A triangular pyramid. All right, let's talk about these cross sections. Remember, it's like cutting it and looking at what's inside of it. A vertical cross section is the same as perpendicular, which I wrote that in blue, perpendicular. A horizontal one is the same as parallel. So I would try to do these on your own. I'd pause the video and try all 7 through 14. Okay, I'll try those. Okay, a vertical cross-section of a cylinder. We answered this on the last one. The perpendicular cross-section of a cylinder is a rectangle. Same horizontal cross-section is a parallel cross-section, so it's a circle. Cross-section of a sphere, not through the diameter, is always a circle. It's a circle. You cut a sphere any way, you're going to get 2 circles. They might not be the same size circle. Like they're not going to be the diameter, it's not going to be the radius, you know, but it's not going to have the same radius as the diameter, is what I mean, or the same radius as the whole sphere. Right? Horizontal, meaning it's parallel, cross-section of a square pyramid. By the way, in a pyramid, a horizontal cross-section is always the same as the base. It's a square pyramid, so the base is square. The cross-section is square. Okay. Vertical cross-section of a square pyramid through the top vertex. Meaning, it's going to go straight through. I drew a square. This creates whatever these sides are. So that is a triangle. All right, a vertical cross section of a square pyramid, not through the top vertex. This is where it's a little bit more difficult. Since it's not through this top vertex, it actually cuts through the sides. Okay, so let's think about just one side. If it doesn't go and slice straight down, that means it's actually slicing from one of these points straight down. Well, this is the figure that's created. This figure is a trapezoid. So it creates a trapezoid. Okay. A horizontal cross-section of a rectangular prism. A rectangular prism cross-section is always a rectangle. Okay. What can be said about the shape of a cross-section that is parallel to the base of a solid? The shape and the base are always the same if it is parallel. All right. Examples 15, 16, and 17 are something different. It says, describe how to generate each three-dimensional figure by rotating a two-dimensional figure around a line. Here is what this means. I'm going to draw a cone. I'm going to draw a line straight through it. What it's asking you is, what is this shape right here? What two-dimensional shape is that? And that just so happens to be a right triangle. Now, here is what is actually being asked, even though this is how you find it. Here's what's being asked. If I take this two-dimensional shape and I turn it around over and over again, when will it make a cone? Well, if I take a right triangle and I turn it over and over again, it will make a cone. This is, you may or may not have seen these before, and I wish I had one, but I don't. But back in the 90s, they would have these tabletop decorations or things that you would hang down that came flat, and then you would take and you would pull them out. If I can find an image of one or something, I'll put it with the video. But you could take and you could pull them out, and they actually created a rounded shape. That's actually what it's asking for here. All right, number 16 is a sphere. Let's draw a sphere, which mine's just going to look like a circle. But here's a sphere. Draw a line through it. It's asking you, what is this? And that is a semisphere or a hemisphere. Either answer is correct. You will more than likely hear hemisphere and a semisphere. Not sphere, a circle. A semicircle. Sorry, two-dimensional shape. Semicircle. Okay. And last is a cylinder. A line straight through it. What is this? That is a rectangle. Like I said, if I can find an image of what I'm talking about where it rotates, I will definitely put it in there. All right, so we're going to cut this as well and glue it in. I cut that a little bit too close. And glue it in on page 143. And I don't know why in the world I put 19.3 on this. So if you did what I did, please go change it. I'm going to erase it right now and change it to 19.1. I don't know where I got 19.3. 19.3 was surface area of something. We've already done that. Alright, so you're going to do some homework over this out of your book. I will attach that video if I can find one. But go ahead and start on your book assignment.